Alright, so let's look at slew rate in an operational amplifier. So let's say that we hook an operational amplifier up in a unity gain configuration, our simplest gain configuration. We feed our output directly back to the input, the inverting input, and we put our input into the non-inverting terminal. And we know that our output over input, our gain, should equal 1. Of course, what does this mean? We know that our voltage gain in any op-amp should be equal to 1 over beta, so it means that beta is equal to 1, which makes sense. Beta in this case is just a wire. Okay, now we also know that our operational amplifier has a pole associated with it, so we can further say with respect to frequency, our output over input with respect to frequency is equal to 1 over 1 plus S divided by omega 1, where omega 1 is the pole frequency of the op-amp. Conversely, we could write this in terms of a time constant and say that it's equal to 1 divided by 1 plus S times tau 1, which is the time constant of the op-amp. Now let's assume that we have a step input to the op-amp. So our input signal, V sub I, with respect to t, looks like this. It's 0 until some point in time, which we might reference as time 0, at which time the output jumps up to a value of VA. And we know that VI with respect to S is equal to VA over S, which is the Laplace transform of a step function. Alright, so here we have that V out of S is equal to VI of S times 1 over 1 plus S times tau 1. VI of S is equal to VA over S, so if we put that in, if we substitute that in, we can write this whole expression out as VA divided by S minus VA over 1 plus S over tau 1. And if we apply the inverse Laplace transform to convert this to the time domain, we would see that V out with respect to time is equal to VA times 1 minus e to the minus t divided by tau 1, which is related to the pole frequency of the op-amp. Alright, so this is our expected response, and so we expect our output to look like this. So we put our step in, we expect our output to approach the amplitude of the input. So we come up to time 0, the step is applied, and our amplifier will respond exponentially, so we should get some kind of exponential rise up to the desired value of VA. What we actually get in most operational amplifiers is we put our input in, and we're measuring our output. We expect to see this exponential increase, and instead at time 0 the step is applied and our output rises linearly with respect to time, and the slope here is dVo by dt, and this slope is equal to the slew rate of the operational amplifier. In other words, it's a change in voltage over a change in time. And so the question is, why does the actual response not look like the expected response? And we'll address that in the next part of the lecture.